integration becomes a reality, building blocks and challenges. And Markus will present us the case as well, Berlin. Just before we kick off the webinar, we have some little housekeeping. So please mute your mic once you join. This will help everybody to understand each other very well and have no disturbance. Now, if you want to ask a question, simply put it in the chat box and we will collect it, or alternatively raise the hand and we will contact you. And that's about it. And I will hand the word to my colleague and director, Paul Voss.
Good afternoon, everybody. Welcome to this latest edition of our Ideas That Move Us Forward series. We're going to talk about smart sector integration today, and we're going to look in some detail at how to turn this concept into reality, what it looks like on the ground. And we've got a great story in Berlin and a great speaker in Markus Witt. But first, a few minutes of history from me, maybe on quite how we got here. It's a good few years ago now that I first started to hear about the concept of smart sector integration as it pertained to district heating. Specifically, this notion of using district heat networks as a kind of thermal battery. So taking excess wind power when it was available and using that to power large heat pumps, which can subsequently feed the district heating network. And I realized quite quickly that we were onto something useful. First of all, as a political concept, because as those of you who work in the heat business may be aware, it is sometimes more difficult to get politicians excited about heat than it is to get them interested in electricity. And I noticed that when I began to pitch this concept and talk to them not only about a district heating network, but about its interaction with the power grid, it was an idea that excited them. There's a kind of win-win there in being able to take up this excess wind and do something with it. And I noticed that it was a very appealing and even seductive concept. Now that's one thing, but the problem we have right now with our energy transition is I think we probably have a few too many seductive concepts that are exciting to talk about, that look great on paper, but don't necessarily lead to anything in real life. What we need right now are things that work. The energy transition is difficult, whatever way you look at it. So we need anything that we can find that's going to make this easier and cheaper and faster, because we don't have time or money to waste. Now, those of you who follow the Brussels energy debate closely will know that this is now a very live discussion in Brussels. The European Commission published a strategic communication on smart sector integration last month, and it has gone from being kind of an esoteric niche topic to actually what is the or one of the flagship political initiatives of the current Commission. They want to talk a lot about sector integration. And when you read the paper that they published back in July, and I encourage you to do so, you can find it on our website and elsewhere. One of the great things that emerges is there's a very clear and prominent role for district heating networks in it. And again, district heating was probably something of a niche topic 5 or 6 years ago. And one of the things that has helped us move closer to the center of the policy debate is this link up with electricity and the wider energy system. The sector integration communication talks about the need to accelerate the development of heat networks. It talks about the need to finance flagship projects, particularly in the area of power to heat. So that's great for us. And more broadly, what it's helped us do is kind of join the broader EU discussion about energy system design, about infrastructure, conception, and planning. And that's a really useful thing, because in the end, all these things are connected. If you don't understand what's happening with heat and with district heating in particular, you don't know enough about the future of gas in heat, for example, or you don't know enough about the future of electric heat, where it's going to be needed, where it won't be needed because district heating can do the job, and so on. So this idea of not only integrated system design, but integrated thinking as we plan the energy transition, it's really positive, I think, for the transition in general. And it's hugely useful for district heating because it really has lifted us up and helped us enhance our profile and our visibility in Brussels. Now that's all very abstract. That's our job, to deal with these things in the abstract. Today what we're going to do is zoom in to the vibrant city of Berlin and look at what they're doing with all this on the ground. I was lucky enough last year. I think that we should have a photograph. It will come when Markus starts to speak. What you'll see is a picture because I visited Berlin last year with my counterparts from the gas and electricity sectors. And we spent a day trailing Markus, following him around Berlin, looking at the way Vattenfall is approaching this problem, because they really have a huge role to play in delivering this in the city of Berlin. There we are, and there's Markus with us. And that was a great day for me because I saw that these things that we talk about so often in theory are actually happening in practice. And one of the key people responsible for making this happen is Markus Witt. And spending time with him that day and before and since, I've been hugely impressed with his passion for this project, with the determination and the conviction that it really can be accomplished, that kind of pours out of him when he talks about this. You feel his enthusiasm and his energy and his excitement about the project. And I think that excitement is really quite infectious. So we're very happy to have the opportunity to have him with us here today to share in detail what this looks like. And with that, I'd like to thank Markus, thank Vattenfall for their efforts in making all this happen. And with that, I'll hand the floor over to my friend, Markus Witt. Markus.
Yeah, Paul, thank you very much for this warm introduction. And I really hope that I can as well transfer or transport a little bit of this passion which you have described just now. And I'm very happy also to be with you. And a warm welcome also to everyone who has now connected to this webinar. And yes, indeed, it's in Brussels, we can be, as an association, as an industry, we can be very happy about the developments which we see. So being in the really recognized as an industry, but also, of course, as a utility, much more on eye-to-eye level with electricity or, for example, gas. So if we look to Berlin, what do we do in Berlin, and what are our plans when it comes to smart sector integration? Maybe just a few words about the Berlin heat market, and there we think we have a good starting position to support our decarbonization strategy, which we have as Vattenfall. We try to support our customers with fossil-free living within 1 generation. So that's where our district heating in Berlin can play a vital role, as we think. On the left-hand side, you see the Berlin heat market, which is still fossil-dominated, so many boilers based on oil. 40% of the heating market is gas boilers, and then there's district heating with about 1/3 of the market share, which corresponds to about 10 terawatt-hours of heat generation, which is not small, I would say. And of course, this is, if you look to the right side, to our, let's say, some of our key KPIs, which corresponds to roughly 1.3 million living equivalents, which we supply and provide with warm water and a warm apartment. So this is the B2B customers, which are housing corporations, and they are about 5,000, which we have in our portfolio. And behind that, there are many, many apartments. Our company is has about 1,450 employees, and the grid length is about 2,000 kilometers. That, I think, is enough about the company as such. Berlin as a capital of Germany, and if you look to the history, 1990, the wall came down. Almost everything changes or has changed since then, and of course also the way energy supply is done from 1990 to today. And that's something you can really also see in the overall CO2 emissions of Berlin. So back in 1990, almost 27 million tons per year. And you see in gray all other sectors except Vattenfall, and Vattenfall is in blue here. So you see that until 2016, we could or we have reduced our emissions by 50%, whereas the city of Berlin, so all other sectors, which is mainly housing, not housing, but mainly transport, a little bit of industry and small business. So they could only reduce emissions by about 24%. Towards 2021, so towards the right side, we have taken some new plants into operation. We shut down some plants just lately, so which then again reduced our emissions by 1.3 million tons. So now we are standing around 5.4 million tons, 5.2 million tons CO2 emissions. And that's our starting point now for any further CO2 reduction. So about 60, I think even more than 60% since 1990. And on this page here, you see Berlin with a map, and these colored areas, these are supply areas for district heating. So we have 4 supply areas, 2 in the western part and 2 in the eastern part. And they're actually also technically quite different because of historical reasons. So the GDR developed a 2-pipe system in East Berlin, whereas West Berlin built in the past a 3-pipe system. We have 6 sites which are really important for our decarbonization strategy. And as you can see, until 2030, our focus point is the coal phase out. So, and this coal phase out means that at 2 sites, which is Reuter West and Moabit, which you can see here on the top left part, there we still produce heat, and this is about out of the 10 terawatt hours, you can say this is about a quarter of the overall heat production. So there, the target is to replace hard coal by a mix of different sources. And there I go into the details. Moabit is will be mainly a biomass based. We also look into geothermal and into a motor CHP. On the left side, so Reuter West, which is the baseload, huge baseload plant. There we look into further utilization of energy from waste, but also a heat pump. And so we talk about smart sector integration, of course. And we also look into a, as we say, hydrogen-ready hybrid CHP. Then you see other sites which are gas-fired, and also in Lichterfelde, so the lower left side, we just recently took a new CCGT into operation, and also in Marzahn, we just this year in June, so not long ago, we took a new CCGT into operation. So we work on the total entire asset portfolio to be more efficient, and of course with that reduce our CO2 emissions. Post 2030, we will have kind of second investment wave, as I see it, and there we will certainly look into further electrification. This also has something to do with the infrastructure around Berlin. So there, the transmission system operator needs to do some investments before we can really, on large scale, and here I talk about roughly about 1 gigawatt of power to heat, which we would like to implement in the system. So 1 gigawatt, not just power to heat direct, so direct heating, but also in the format of large-scale heat pumps. And then comes a time, then let's say post 2035, 2040 and beyond. And there we think that it will be possible to replace the remaining fossil part, which will be a mix of biomethane and natural gas, which we will then, of course, also replace with hydrogen, which we think will be in the system. So far, as an introduction, when it comes to our system, are there any questions up to now? then I could take, if there is, I could take a question.
Again, you can just unmute yourself and ask the question, or type it into the chat box, and we will deal with it. Thank you.
Okay, maybe not. At least I can't hear, and I can also not see any question. Then I just continue. So I talked about, if I go back here, I talked about Reuter West, and that there is a hard coal-fired plant which we are going to replace until 2030. Yeah. So, and how do we do this, and how do we, from a system perspective, use this smart sector integration idea to really go for smart solutions. So, and you saw the picture in, also with Paul and myself in the beginning, and this is was here in the, as you can see on the upper left side, this was in a plant which we took last year into operation. This is a power to heat facility, and you see this is located here in an area in the northwestern part of Berlin, where we have the pleasure, you can say, to integrate our own premise. This is here, this green area, on where today we have also located this Reuter West hard coal-fired plant. So, but there's also this blue area, which is a sewage, so a water cleaning plant, where sewage water from the city is cleaned. And then there's this orange part, and there is a waste incineration unit from the waste collector company of Berlin. So, so this is where we do smart sector integration, because we have already built this power to heat facility. We are just in the preparation of a final investment decision for a large heat storage. So here I talk about 50,000 cubic meters of hot water heat storage. And this is something we have just recently also where we have signed contracts with this wastewater company. And that's where we will build a heat pump, large-scale heat pump, capacity of about 30 megawatt thermal plus X. It depends on how much energy we can really take from this cleaned sewage water, which we will transport with a new pipeline, which is to be built here along this river Spree and then over a bridge to our own premises. So that's a building block of this replacement of the hard coal-fired plant. And then something that comes on top, and that's what we do today, and we will even more do in the future. This is the utilization of this energy from waste. So there's this bridge which I said, and we do not only take this water in the future, but also we take already today all steam which is produced here from the waste incineration plant. There we will build a new steam turbine probably, and then replace an old turbine which is here on the right side. And then on top of this, there are plans, and this is based on a feasibility study which we have done together with the city of Berlin, how to integrate really all energy which is produced here in this waste incineration plant, which means they are also looking into flue gas condensation. And then we integrate this hot water as well in our district heating network. So this site here, this green area in the future, will not only have a power to heat unit, corresponding heat storage, but also a second, I would say, ambient heat source, which is this water. And this will all be integrated into the overall system. At the site, we are planning to replace this hard coal plant with something which we call a hybrid CHP plant. So on the left side, you see a standard CHP, gas-fired CHP with its PQ diagram. So here's electricity production on the Y axis, and there's heat production on the X axis, and there's a certain ability of the plant to deliver at the same time in CHP mode electricity and heat. And with those components which I just explained, so there's a heat pump, there's maybe a steam turbine bypass, but there's also a power to heat unit and heat storage. So with all these components, it's possible to enlarge this operation field, this PQ diagram of the site to a great extent, which of course brings a lot more flexibility and a lot more possibility to integrate green electrons into the site and into the district heating system. And on top of this, this unit will be hydrogen ready, and that's something of course more long term, but that's something also we prepare for already today, and that's what you see here. So there is these blue lines and circle. This is the high pressure gas pipeline system around Berlin today. And we are in the planning phase. We have started the official approval processes to bring new pipelines to the site of Marzahn and then also later to Reuter West. And those pipelines will be hydrogen ready. And on the left side, you see a picture of this new plant Marzahn. And that's something in parallel, we are also pursuing right now. And you might have also heard that there is this hydrogen strategy from the German government. There's quite some money available. And that's something we want to also use and prepare ourselves to use hydrogen in the future, which means at this site of Marzahn, we are planning and we have the outline of this to apply actually for money is already at hand. So we plan to have an electrolyzer, produce hydrogen at site, store it at site, mix it with natural gas coming from the high pressure system, and then test the turbine, this Siemens turbine, which we have there, and which is capable to burn up to 27–30% of hydrogen. And there we think that this is something we have to do in the near future to prepare ourselves for a situation in the 30s, 40s, where hydrogen becomes simply a part of the overall gas system. So for us, at least, this is also a part of smart sector integration. So it's not just green electrons, but also green molecules, which of course have their origin in from green electrons. So that's a step we are also pushing forward in our organization. Maybe to sum it up, 2030 coal phase out. This is for us, also from a company perspective, something which is really important, and we think that there's not just one way and one route to go. No, we think up to 2030 it's necessary to have a diverse portfolio at hand. So we look into all these components which I have just described, and then towards the 2040 and 2040 plus situation, there we have to adjust the portfolio further on. So there is certainly more sector integration, so certainly more power to heat, or local renewable heat sources, of course, as well. Wherever possible, we should integrate them. There comes hydrogen. In some areas of Berlin, and you might know, Berlin is really a growing city, so there will be decentralized solutions. Maybe we can also connect these sources to the overall network. Then there's biomass, and biomass, of course, is always a tricky discussion when it comes to sustainability as well. So here we have to be very careful, but at least we think that biomass can also play some sort of role. Yes, and on the right side, you see requirements, but I'm sure you already read through these requirements, because of course it's not a simple approach, and it's also so that you really need a lot of developments around Berlin, in Europe and in Germany, to make certain items here really happen. But it overall, from an overall scale, it follows one idea, and this is this idea of being an integrated system manager. So smart sector integration is part of an overall role which we see for district heating in Berlin, and even more so in the future. And this is something where which goes also along the complete value chain. So it's not just the upstream part, so where do we get our heat from, but also very much the downstream part. And that also back and forth, which means, and this is here these red dotted lines, we are deeply involved, and we are working on the rollout of smart meters at the customer side. So to really have much more transparency and to digitalize much more our steering towards the end customer, which of course in turn, as this is all integrated into our control room, we have much more flexibility to switch between power to heat, efficient gas-fired heat production, energy from waste, or the integration of some renewable heat sources. So that's the idea for our, you can say, more long-term steering of our district heating network in Berlin. So far, my presentation, here are some contact details, and I'm sure, but also I hope you might have now some questions.
Yes, Markus, we actually have 3 questions in the chat. I may read out the first one for you. It comes from Yuri, who is asking, will you and how will you introduce switch to low temperature supply to be able to include even more renewable energy and storage?
Yeah. We have a project internally which looks into the question, which measures are necessary to also reduce, of course, our flow temperatures. So in the western part of the system, we have a temperature which is between 80 degrees and 110 degrees as an outflow, so variable over the year. But in the eastern part, it's the maximum, you could say, at design temperature is about 135 degrees Celsius, so quite high still. Then it's about low temperature heat sources, and we are very keen to actually connect, for example, data centers, very keen to connect, you could say, even solar thermal. Both solar thermal and data centers, they're simply not available in Berlin. So, and that's, I would say, is not because of our temperatures are too high. This has other reasons. We think that we have to make some steps, but also it's possible via heat pumps to also integrate this low temperature heat sources into the system. So from our side, we are open. The supply or the offerings from the market is very low. There's very few people or companies which come and ask for connection towards the heat system.
Yes, thank you so much, Markus. I think that sufficiently answers the question. If not, Yuri, you can of course basically pose a follow-up question. I would then move on to Axel, who has a question that's not touching on renewables, but something closely related, and it's waste heat. So he's asking if there has been a screening of the potential of industrial excess heat to be used in the district heating system in Berlin.
Yeah, very much. We have actually a map of all possible sources in the city. So unfortunately, and that's what I think I said it in the beginning, Berlin is a city of administration, so the capital of Germany, of course, with a lot of administration, but with very little industry. So we look and we know each and every source, and we are in talks with different sources. It's very difficult to bring them really into the network. And some sources are simply far away, and there is also not for the source a business case to really be or get connected. But whatever is reachable, and of course also fulfilled certain requirements when it comes to some technicalities, as you know, we are in talks.
Okay, excellent. Thanks a lot, Markus. Now let's move on to the next question, which comes from Jelena, and she's actually asking about other players on the market. So do you have any insights if competitors have a similar approach to system integration and what their unique selling points are?
Sorry, could you repeat this question again?
Yes. Do you know if there are other competitors that have a similar approach to system integration and what their unique selling points are?
Yes, to a certain extent, yes. I mean, we do have, of course, our colleagues in Hamburg, and we do have colleagues in, for example, Munich. So if I take these two cities as examples, and I now stop this presentation, but maybe I should go back to the presentation, which is maybe simply nicer to see here. So if I take two examples, Hamburg. Hamburg has also a goal to be fossil free as soon as possible, and to make district heating much cleaner in the future. The approach is quite similar to ours. The advantage of Hamburg is that there is much more industry available and also energy from waste available. So this integration of different sources is, as I said, for Hamburg very similar when it comes to the focus of sources and industry. If I look to Munich, Munich has a different prerequisites. So there, for example, geothermal as a source is much easier to use. So they develop different geothermal sources, but still also, for example, have a coal-fired CHP, and there's also the same discussion how to replace and how fast to replace this coal-fired CHP. So in such cities of, let's say, similar size, the discussion and the way to integrate sources is actually quite similar.
Great, thanks so much. Actually, for this question, I would like to also hand it over to Paul, if he can give us a little bit more insights on the whole European landscape, if that's okay for you.
Yeah, that's okay for me. Thanks, Sophia. Yeah, I mean, first of all, I would second what Markus said about the fact that one of the considerations that's so important with a district heating setup is the availability of the local resources. So the approach in an administrative city like Berlin will, of course, be different from one with a heavier industrial base like Hamburg. More generally in Europe, what we see is that this system integration, particularly as regards power to heat, is already very well established in what I would loosely describe as Northern Europe. So it is really standard business already in the Finnish market, in Denmark, where I think they would be unable to conceive of a system that didn't work this way. It's simply part of the way they're set up these days. In other parts of Europe, it is there is, let's say, an emerging interest. I know, for example, in the Czech Republic, quite a lot of power to heat has come online over the last couple of years. We consistently hear that there's an interest, but one of the other things that we consistently hear is that tax conditions, particularly taxation of electricity, tends to discourage or disincentivize this practice. And I know that the sector integration discussion at European level has already resulted in growing awareness of the idea that in order to fix this or help encourage it, it will be necessary to work on the energy taxation directive, so the way that different fuels are taxed according to what they're used for and so on. But generally speaking, yeah, across Europe, we see more and more interest in this. You need a growing wind capacity and you need heat networks. And once you have those two preconditions in place and the broader regulatory framework is right, this is something that can really take off.
Great, thanks so much both for answering this question. We actually have even more questions coming in, so very much appreciated. Please keep them coming. Two of them are relatively technical now, so let's move on with them, Markus. So the first one comes from Chris, and he's asking, you mentioned turbines are capable of 30 to 40% hydrogen and 70-60% methane gas output. Do you also consider turbines that can do 100% hydrogen or 100% methane gas output?
Yeah, exactly. That's what we do. As I said here on this slide, which you now see again, hopefully, we have finished, or we have taken into operation this CCGT on the right side, so the eastern part of Berlin, Marzahn, and there the supplier, which is Siemens, says or told us that up to 27% of co-firing of hydrogen is possible without really significant adjustments to the turbine. That's okay-ish for now, of course, and yeah, there is no hydrogen available right now on the market, so that's a start point. But for if you look to the left side, Reuter West, there we indeed plan to look into turbines which can burn minimum 50% or with some modification, but let's say modification where the supplier already can really, there's a, let's say, a development path available, so that we not just 50, but maybe even up to 100% firing of with hydrogen. Yes.
Okay, thank you, Markus, also for answering this one. Now, Oscar is asking, what are the temperature levels can be covered by power to heat, and is power to hydrogen even necessary if you can take the direct path from power to heat?
Yeah, as I said in the here on this slide, it's always, I mean, what are your, I mean, in which situation are you in your area which you act in as a company, which you serve, and their infrastructure plays an important role. So just 2 figures. Our contracted heat capacity, so which we have really connected to the networks, this is 5,000 megawatt. Yeah, and this 5,000 megawatt is something that, of course, is relatively, as a thermal capacity, is relative to the connection of the city to the electricity network is huge. So as a matter of fact, our electric infrastructure around Berlin, the transport lines, 380 kV, they would not be able to provide us with enough capacity in the city to really use and utilize the power to heat, which would be necessary to supply our customers based on power to heat. So I talked about 1 gigawatt, which I foresee is possible until 2035, 40, and that's probably for quite some time the capacity which we are allowed to use from the TSO's perspective. So yes, power to heat is or would be an even nicer solution to utilize this even more, but not possible. Therefore, we need a mix of different sources and have a diverse portfolio.
All right, thank you, Markus. I don't have any further questions in the chat for now, but please don't hesitate to ask any question you have. I also see that Paul raised his hand because I think he might have a question for you. So please, Paul, over to you.
Yeah, hi, Markus. Something that we're discussing a lot with the European Commission at the moment. There is a lot of talk about electrification of everything, and has been for a good number of years. It's sort of one of the pillars of Europe's idea for how to decarbonize everything before 2050. And one of the things I've been trying to get across to the Commission is that electrifying everything, so from steel production to transport to residential heat, will obviously imply, first of all, a great deal of investment in the grid, and second, particularly in urban areas, it seems to me that if you suddenly need to supply that much more electricity into the city, particularly in the winter when you're going to get a peak in heat demand, will you not run into congestion challenges with getting all that electricity into an urban center? And if that's the case, is there a good argument to say that district heating based on other things, say waste heat or hydrogen or something other than electricity, could help reduce the burden on the electricity grid and reduce the need for investments and therefore reduce the overall cost of the transition?
Yeah, absolutely. That's how this is seen, and not just by us, Vattenfall in Berlin, but I think that this insight has already, let's say, become an effect or an accepted fact also in Brussels. Just 2 weeks ago, I was in a seminar together with Mr. Borchardt. So what is he? Deputy General of DG Energy.
Yeah.
And he said basically the same. He said all electric as a scenario is not possible, is seen not also delivers not this decarbonization as needed. And that's also because of infrastructure constraints, of course. And we should utilize the infrastructures which we have in Europe. And of course, there district heating plays a role in these urban areas, highly, densified regions, and where it's even more expensive, to open up streets and to lay down even more copper into the streets. This is really a challenge and really cost intensive. So with other words, yes, it makes sense to just a figure. Today we have a carbon footprint with our district heating, which is based still on hard coal. The carbon footprint is 130 grams per kilowatt hour delivered to our customers, heat. If you take natural gas, you are above 200. If you take electricity as a customer, direct heating, it's even based on the mix in Germany, it's still even higher. So we can reach about 1.3 million customers or living equivalents in the city. So let's bring down us from 130 to 60, 50, 0, and in one go in a few more centralized areas instead of working across and through the city to connect, let's say, thousands of small heat pumps.
Yeah, thanks a lot, Markus.
Great. We have much more questions actually coming in, so I will take them by the order that they arrived. And we have actually also a discussion on hydrogen going on in the chat right now. So the first question is coming from Chris. What is the ratio between the annual electricity energy consumption of Berlin and the annual heat consumption?
Oh, good question. With heat consumption, I think Chris not only sees the district heating, and I mean this figure is here, yeah. So the total energy delivered to heat up all the city, if you like, is 31 terawatt hours. The overall electricity consumption energy wise is something like, I would say, 20 terawatt hours, but I don't really know.
Okay, thanks, Markus.
Yeah, Markus, here's Roland. I can support you. 20 is fairly correct.
Yeah, good. Thank you, Roland. But this was maybe only half of the answer. The rest, that's what else? When the question was a bit more, right?
Yes, about the annual electricity consumption.
Yeah, that's the 20 terawatt hours versus the about 31 terawatt hours heat consumption overall. Yeah.
Yes, but that's it. The question was about the ratio, but I think that's fine.
Okay, good. Okay, I thought there was more.
No, thank you. And the next one is coming from Elena, who would like to know more about the excess heat sources. So her question is the use of excess heat sources free of charge in Berlin? For example, the heat from sewage and steam from incineration?
Of course not. Whatever becomes part of a business is not for free, which means that our partners, and this is really, I would really like to stress this, we have a long-lasting relationship, both let's say a long-lasting relationship to the waste incineration or a waste collector company, and here I talk about several decades. And we have a newly established, because a water company, of course, is, I mean, we are very close to a water company when it comes to the fact that we pump around water in pipes. So that makes us really very close, brings us very close. But the fact that we now want to utilize this clean sewage water is something new. And in both cases, so for the steam from the waste incineration company, and also in the case of using the water, this is of course not for free. We have a contract, a delivery contract, and we pay money to these partners in order to use these sources.
Great, thanks a lot for these insights as well, Markus. Now we will move on to these hydrogen comments we got, basically in answer to your reply to Oscar beforehand. So Oscar says, but as you want to produce the hydrogen by fuel cells at your own site, you do need the electricity as well. And my question is if the efficiency is better for power to heat instead of power to hydrogen to heat. And then there are some follow-up comments that I would also like to take. So Bram, for example, says that he agrees with Oscar, the value of pure hydrogen for industrial purposes. So hydrogen as a feedstock is too high to just burn it for heat, and it is not energy efficient.
Yeah, I agree. I agree with especially with the second comment. To use hydrogen in district heating is, if you look to the merit order of costs to avoid CO2 emissions, so to decarbonize industry, of course there are applications which come first, and this is most probably in the transport sector or in the oil and chemical sector. So that's where the hydrogen will go to in the beginning. Yeah, we think that more long term. So once electrification of industrial processes has been done, and also there is a let's say, a grown market for hydrogen, green hydrogen. And of course, you could now start to discuss the different colors of hydrogen, but let's not do this right now. So let's assume there's hydrogen available in the market. Yes, it goes first into industry and then second and later into the public or the overall networks. And for that situation, we prepare ourselves. We might even see some direct hydrogen deliveries, which are maybe also long-term coming not from within EU, but from outside EU, which we could use. When it comes to this example, which I made here at the site of Marzahn, this is this slide here. This is not meant to be a project which continuously delivers hydrogen based on a PEM electrolyzer into this Marzahn plant as a standard source of hydrogen to be used for the CHP. So this project is a kind of pilot, so a lighthouse project, you can say, to prepare our organization. So our colleagues in operations in this plant to handle this fuel hydrogen, which has some much different chemical and also physical Eigenschaften, properties. Yeah, no, exactly. So which you have to learn to handle. So that's the idea behind this project. Yeah? It's not meant to be like a as the colleague said, to be used as a fuel cell.
Okay, thank you so much, Markus. I do not see any further questions in the chat now. If anyone still has a question, you can also simply raise your hand, which might be a bit quicker. Okay, I think all the questions are answered and all our attendees are happy for now.
Yeah, if there are no more questions, I can only say thank you very much for listening. And you have my contact details. And if there's anything afterwards or later, then please just drop an email. Yeah.
Okay, thank you, Markus, for the presentation, and thank you everybody for making the time to join us this afternoon. Please do get in touch with Markus if you need any more information, and please don't miss our next webinar. There'll be details about that. Thank you very much, and have a nice afternoon.
Thank you.